All right, so we're going to finish up section 7.2, which is on inverse trig still. And we're going to look at a couple things. We're going to look at a way we can take a formula like that and simplify it. Okay, so it's not as complicated, doesn't have any trig in it when we're done. So we're going to be able to get rid of those two trig functions. And then we're going to finish up by looking at how to solve trig equations. Okay, so we've done that a little bit graphing. We're going to focus more on how to do it algebraically, and I'm going to give you a chart that shows you how to do it. And it's going to tie in what we did with the reference angle. So remember we had formulas, 180 minus the reference angle, 180 plus. I'm going to tie that in to this last thing here. All right, so the goal in the first part is to take a formula that has trig in it. Okay, trig means it has a function like sine, cosine, inverse cosine, something like that. And we're going to come up with a way to get rid of that and have just an algebra expression. Okay, algebra means there's no trig, no sines, no cosines. You can't have any of that in an algebraic expression. You can have squaring, square rooting, add, subtract, multiply, divide. You can't have any of that, but just no trig. Right? And for some equations, we can get rid of the trig, and I'm going to show you how you do it. So the way we're going to be given these problems is there's going to be two trig functions. I'm going to have an inner, and then I'm going to have an outer trig function. When I say the inner trig function, I'm talking about the one inside the parentheses. The outer is the one that's in front. Okay, so the goal, the key is to start with the inner trig function. And what you want to do is somehow draw a diagram for that inner trig function. Okay, so we'll look at the inner trig function, think about what it means, and then draw what it means as a picture. Part of drawing that diagram is going to mean we need Pythagorean theorem. So we are going to use that again. When you're working with the inner trig function, if the inner trig function is inverse trig, like this one, that's inverse trig, and that one is also inverse trig, it's going to help to think of that function using regular trig. Right? And I'll show you how we do that. Okay, so if the inner trig function is an inverse trig, we're going to try to think of it a little bit differently as regular trig. That's what's going to help us to draw the diagram. Okay. So keep in mind the Pythagorean theorem. That is definitely something we'll use as we go through the problem. Okay, so the nice thing about this process is it's exactly the same every single time. It just takes going through it once or twice to kind of maybe understand what's happening. So let's take a look at this one. It says write an algebraic expression for that equation. So when we're done, we're not going to have any trig left in the problem. We're going to convert it purely into something that's algebraic. Okay, so first thing it says is to start with the inner trig function. So for now, forget about sine. We'll come back to that at the very end. Okay, let's start with the inner trig function. The inner trig function is inverse cosine. When you do inverse trig, what are you trying to figure out? Why would you ever use inverse trig in a problem? Only use it if you're trying to find the what? The angle. Yes. So anytime that you use inverse trig, you are trying to find an angle. I don't know what the angle is in that red box. I don't know. I'm never going to know in this problem because there's variables. But I do know that it's going to come out to some angle. How do we usually represent an angle in trig?
Beta.
Theta, alpha, yeah, we use a Greek letter. So let's just use theta. So I'm just saying what's inside that red box, it's going to come out to some angle. What angle? I don't know. Okay. Now, I want to take that and I want to rewrite it using regular trig. Okay? That means I want to get inverse cosine to disappear. How would we get rid of inverse cosine? Yeah?
Multiply both sides by cosine. Take cosine of both sides.
Take, exactly. That's what I was getting at. Take the cosine of both sides. So we're going to take the cosine of what's on the left. And we're going to take the cosine of what's on the right. When we do that on the left, what happens? They cancel out. So now we have v equals, and what's on the right side? Cosine theta. All right. Now let's draw a picture of that. Is the left side a fraction right now? No, I do want to make it a fraction. How can you make anything into a fraction? Yep, divided by. What can I put in the bottom? 1. Okay. So I have an equation that says the cosine of theta equals v over 1. What's the definition of cosine? Yeah?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So that equation is really telling me two sides to label in a triangle. It's telling me the adjacent side is a v, and it's telling me the hypotenuse is a 1. So let's draw that out. Doesn't matter where you put theta, just put it as one of your acute angles. Label the adjacent side v, label the hypotenuse 1. Okay. Any question how I converted that equation into an image?
Can you repeat what you did?
So we know that the definition of cosine is adjacent over hypotenuse, and the adjacent side is v, and the hypotenuse is 1. All right, now think back to what they wanted in the very first step. They wanted the sine of the diagram we just drew. Okay? We just represented that box as a diagram. Now we need to take the sine of the diagram. Sine is what over what? Yep.
Opposite over hypotenuse.
Opposite over hypotenuse. Okay. Do I have the opposite in that picture? No. I don't have this. I need that. Based on what I've labeled, how can I figure out that third side?
Use the Pythagorean theorem.
Yeah, we'll use the Pythagorean theorem. So you can temporarily call it whatever you want. Call it A, I guess, whatever you want to call it. But in a minute, we're going to have a formula for what A is. It's not going to be a number because the other sides are not all numbers. Okay? It's going to be a formula with a V in it. So let's set up the Pythagorean theorem. So A squared plus V squared equals 1 squared. Okay. What would be my next step to start to solve this for A?
Get the v on the other side.
Okay. And how would we move the V squared to the other side?
Subtract it from 1 squared.
So we're going to subtract it. I'm also going to square 1 because that just comes out to 1. So I have A squared is 1 minus V squared. And now how would I get rid of the exponent of 2 on the A?
Square root.
Take the square root. So A is the square root of 1 minus V squared. Now I know all three sides of the triangle. I don't have numbers for all of them, but I have an expression for all of them. Now you can answer the question. What is the sine of the diagram that we drew? Sine is opposite which is 1 minus v squared, over hypotenuse. But what's my hypotenuse? It's just 1. So that's all I need. And let me show you, if you type in a number for v, how that would work. Okay. Let's type in like 0.6. Let's do the sine of the inverse cosine of 0.6. Okay, and I'm going to do this in radians. Okay, hit enter, and I get 0.8. That's the answer. Now, let me type in 0.6 into that other formula, and if we did it right, that formula on the right should give me the exact same thing that I just got. Let's do the square root of 1 minus 0.6 squared. 0.8. Exactly the same thing. So what I did is I just converted a formula that had trig into a formula that does not have any trig. Right? Try it with another number just to show you it works. Let's try 0.7. Right? Let's do the sine of the inverse cosine of 0.7. Okay, we get that number. Now, let's plug 0.7 in, do the square root of 1 minus 0.7 squared. Oops. Having trouble. There we go. Exactly the same answer. So that's the process. We'll go through it again now. If you want a faster way to check answers, you could put the top one in y1, put the bottom one in y2, and you could graph them, and you would see they look identical. I guess I can show you that real quick. I'm not going to go through showing as much detail on all of them, but this is the first one, so why not? All right, let's do zoom 6. I'm going to have to zoom in, make it so you can see it better. Zoom in. Okay, that's the left side. And that's the right side. They're exactly the same picture. They're the same thing. Okay, any question on that? You don't have to worry about sketching that. I'm just sketching it to show you visual. I showed you with a few examples. I want to show you graphically that they look exactly the same. All right, so let's try this one. Okay, it's the same idea. I want to start with a certain function, and we're going to work with that. What function am I going to start with here?
Sine?
Yeah.
The inverse sine.
Inverse sine, yep. Start with the one that's on the inside. And we're going to set it equal to something. Anytime you use inverse trig, you're always trying to figure out the angle. So let's represent a generic angle on the other side.
Theta.
Theta, yep. Now I want to draw a picture of that. In order to draw a picture, it's going to be more helpful to think of it as regular trig rather than inverse trig. So what could I do to get rid of the inverse sign and just have regular trig? Yep.
Take the sine from both sides.
Take the sine on both sides. When you do it on the left, those cancel out. And that's what you get when you do it on the right. So now you have v equals sine theta. You always want this left side to be a fraction. So how can I make v into a fraction?
Put it over 1.
Yeah. If it already was a fraction because of the information in the problem, then that's fine. Like if this was a v divided by 2 in the original, you would have already had a fraction. Okay, but we didn't. Okay, so now we've got the sine is v over 1. Make your picture. What, if they tell me the sine, what two sides have they given me?
Opposite and hypotenuse.
They've given me opposite and hypotenuse. So make the opposite v. Make the hypotenuse 1. It's basically very similar to the diagram we just had. It's just something switches. All right. Now, what trig function do they want us to do in this diagram? They want the tangent. Okay, so we made a visual of the inside, and now we're going to do the tangent of what we just drew. Tangent is what over what?
Opposite over adjacent.
Opposite over adjacent. I don't know adjacent, so I need to solve for it. Okay, this is going to be the exact same Pythagorean theorem we just did. A squared plus v squared equals 1 squared. Bring the v squared to the other side. And what was the last step?
Square root.
Yep, square root it. That's A. All right, so now we can find the tangent of the inverse sine, or the tangent of the diagram we drew. What side is opposite theta?
B.
V. And the other side we need for tangent is
Adjacent.
adjacent, which is
Square root of 1 minus v squared.
square root of 1 minus v squared. And because we have a square root in the bottom, we should fix it. What will we multiply the top and the bottom by?
Square root of 1 minus v squared.
Yep. So v square root of 1 minus v squared over 1 minus v squared. That's the formula for the tangent of the inverse sine. Okay, let's try it. I'm just going to type it in so you can see they look the same. There's the tangent of the inverse sine. And it doesn't matter how you type it in. I'd want this as the final answer on paper, but if you're just checking to see if we did it right, I guess you could type in either one of them. I'm going to do the first one. So I'm going to do x divided by, x divided by 1, how am I going to do that? The square root of 1 minus x squared. I think that should be okay. Let's hit graph. Okay, I don't really care what it looks like. I just want to see, do I get the same graph twice? And I do. That doesn't prove that it's right, but it definitely suggests that we did it right. Okay. Any question on how we did that one? All right, let's try one more where the inverse is on the inside. Let's try this one. The cosine, we're going to come back to example 2. Let's do the cosine of the inverse sine of a half. What do you notice is different this time about the argument to the inverse sine? Yeah, it's not a letter. That means when we get our answer to this problem, it is going to be a number. Okay, it's going to be an exact number. All right. Okay, what trig function do we start with?
Sine. Inverse sine.
Inverse sine. And we know that the inverse sine of a half is going to come out to a what? What kind of?
Angle.
It's going to come out to an angle. We don't know the angle right now. Okay, we're not going to use a calculator to figure it out. So how can we represent it? Yep, let's just call it theta. Now, what could I take on both sides to think of this with regular trig?
The sine.
Take the sine. What will that leave me with on the left?
1/2.
And what will that leave me with on the right?
Sine of theta.
Sine of theta. So now I'm going to label a triangle, but it's going to be all numbers. So this is actually a little easier in terms of you won't have any letters. Okay, we know the sine is a half. That means the what side is 1?
Opposite.
Opposite. And the what side is 2?
Hypotenuse.
Hypotenuse. And how do you find the third side?
Pythagorean theorem.
Okay, Pythagorean theorem. So 1 squared plus a squared equals 2 squared. Okay. 1 squared gives me 1. 2 squared 4. So how much is a squared? 3. So then now, how much is a?
Square root of 3.
Square root of 3. Okay. So now let's go back up to the original problem. In the diagram that we just drew, they want to know the what? The cosine. Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Okay. So now let's check. And that's when we can see if we did it right. Okay, take the cosine of the inverse sine of a half. We get 0.866. Take the square root of 3, divide by 2, and we get exactly the right thing. See, the problem though is if you try to type it in that way on the calculator, it's going to tell you 0.866, but I'm going to ask for the exact answer. So that's how you get the exact answer.
It would be square root of 3 over 2.
Square root of 3 over 2, yep. If it says exact answer and you put 0.866, that's not right. That's a decimal. Okay, so any question on that one? All right, so we'll do one more of those, and then we'll look at the last thing. Okay, what's different about this one? Yeah, the inverse is on the outside. So what that means we're going to do is, like just following PEMDAS, we're going to start with parentheses, and we're going to see if we can figure out the tangent of 3 pi over 4. Okay, we're going to see if we can figure that out. All right, so let's forget about inverse sine for now, and let's copy that down. Okay, I think one step that's going to help us to start to figure this out would be to change radians to degrees. Just make it a little easier for us to think about. Does anybody remember what pi over 4 is in degrees? Yep. That's pi over 2. Yep.
45.
That's a 45. So this is 45 tripled. So how much is 3 pi over 4? 135. Yep. Now 135 is a multiple of what number? Based on what we just did.
45.
It's a multiple of 45. It's 45 times 3. Anything that's a multiple of 45, you can figure out the trig function by using the unit circle. Right? That's why this is going to be doable without a calculator. If this angle was 134, no, you can't do it. But 135 you can, because it's a multiple of 45. So let's draw our diagram. Okay, here's 90. Here's 180. Where would 135 be on the circle? Closer to 90? Closer to 180? Or right in the middle?
Just about right.
It's right in the middle. Yep. So here is your 45, 45, 90. In the unit circle, the hypotenuse is 1. Does anybody remember how long the 2 legs are? They're both the same. Yep.
Square root 2 over 2.
Perfect. Square root 2 over 2. Square root 2 over 2. So now when we write the coordinate for 135, we just have to be careful because we went left and we went up. So what's the coordinate for 135 degrees? What is it? Negative 1, 1 would be like up here. We'd be lined up with the edges of my circle.
Negative root 2 over 2, and then root 2 over 2. Oh.
Yeah. Negative root 2 over 2, positive root 2 over 2. And tangent on the unit circle is when you do y divided by x. So what's y divided by x in this case?
1. No, wait.
-1.
Negative 1. Yep. So we simplified the whole inside part to just be -1. Okay, so now what we want is that. That's a lot simpler question than what we started with. Okay, but that first part, that tied in a lot of different things. Converting radians to degrees, drawing a unit circle, figuring out the coordinate, and then using the coordinate to get the tangent. Any question how we got -1 for all of that? Okay, so now we have to figure out that. Because of the number that's inside the parentheses, that's going to make it easy enough we can figure it out. Unless the number inside here came out to something special like it did, generally you can't just look at it and figure it out. Okay, but that one we can. So now we're going to think about the graph of sine, okay, from the last chapter. Sine looks like this. That's 0. What's the high point right here? Well, the y value is 1. What's the x value? Sorry.
Pi over 2.
Pi over 2. And how about when it crosses the x-axis in the middle?
Pi.
Pi. And the low value right there?
3 pi over
3 pi over 2. And the end of the cycle?
2. 2 pi.
2 pi. Okay, that's the graph of sine. What this is saying is if you draw sine, where does it hit -1? That's what inverse sine means. 3 pi over 2. Yeah. It hits -1 right there. Again, if we were asking where it hit -1, +1, or 0, those are the three numbers we would have been able to do inside there without a calculator. If it said where does it hit like 0.73, you can't figure that out without a calculator. So that's how you figure that one out. Okay, so a lot of special things had to happen to make that work. But that's what inverse trig means. If you draw the graph and you look at that number, like if you draw the graph of a regular sine and you look at -1 on the y-axis, that's what it wants to know. Where do you hit -1? What angle? That's exactly what inverse trig does. It solves for the angle. That's the angle right there, 3 pi over 2. Okay. What if it was a +1? If it said the inverse sine of +1,
Pi over 2.
that would have been pi over 2, because then you draw the graph of regular sine and look at where it hits the number inside the parentheses. Okay, that would have been pi over 2. Right? And what if the number was 0?
It hits it twice.
It hits it
pi
twice.
and 2 pi.
Yeah, it hits it twice where?
From 0 pi and
0 and pi.
0.
Yeah. We wouldn't want to include 2 pi because this point is a repeat of that point. Those two are the same point, just in the next cycle. What's that?
You'd only include 1, right?
You'd only include 1. So if the number inside here said, where does it hit 0? I would say this point right here, and I would say that point right there. I would not use that one. Just those two. Okay. All right, is there any question on that? All right, so the last thing we're going to do is we're going to look more at that kind of thing. Okay, solving an equation. So if you draw a wave, if you draw a horizontal line, how many times, what are the different options that can happen? If you draw a wave and a horizontal line, in terms of how many times they cross.
Cross infinitely.
Okay, it's either going to cross infinitely many times
Or 0.
or 0. Those are the only two things. If the line is somewhere in the range of the wave, it's going to cross infinitely many times. If it's outside the range, well, then it crosses 0. And we know how often it's going to cross. So if you draw a wave, draw a line. This solution is the solution where the line hits the wave and the wave is going up. That's the same solution. It's where the wave is going up and it hits the line. That's the same. That's the same. All those red dots represent the same solution. How far apart, not a number, I'm thinking of a word, in general, how far apart are those two solutions?
1 cycle.
They are exactly 1 cycle apart. How much is a cycle? Well, that depends on the problem. Okay? But they are 1 cycle apart. Okay? Same thing with this. The blue dot is the other solution. It's the solution where the wave is going down through the line. Down through the line, down, and down. And it's the same thing. Each one of those will repeat every cycle. You'll get another one of those answers every cycle. So when they ask us to solve a trig equation, if the directions say find all solutions, then what you have to do is on your, if you were thinking about it as a graph, you would set your window to that. You would find the red and the blue answer by using second calc intersect. And then you would just put like a plus 2 pi n to tell me that that answer repeats every cycle. That's how we've done it before. Okay, what we're going to look at is just seeing if we can do it without the picture. Okay, and I'm going to give you a diagram that's going to help us. Or kind of like a chart. Let me give you a chart. It's actually faster to do it not graphing it. Because to graph it, you got to type it all in, then you got to set your window, then you got to do the intersect. Okay, that takes a while. Let's think of this chart. Okay, we had different formulas in each quadrant once we knew our reference angle to figure out an angle in that quadrant. In quadrant 1, it was just the reference angle. You didn't have to do anything special. Does anybody remember in quadrant 2 what the formula was?
180 minus 33.
Yep, so 180 minus the reference angle. How about in quadrant 3?
180 plus the reference angle.
180 plus the reference angle. And quadrant 4?
360 divided minus the reference angle.
360 minus the reference angle. Okay, so we had that, I think it was on Tuesday or Wednesday. Okay, now I'm going to add something to it. ASTC. Okay, and what those stand for is all, sine, tangent, cosine. Okay, so what does that mean? So I'll write this off to the side. In quadrant 1, all trig functions are positive. In quadrant 1, all the trig functions come out positive. So think of quadrant 1. Quadrant 1 are all the angles between what and what?
0
And 90. So if you pick any angle between 0 and 90, type it in on the calculator. I guarantee you will get a positive answer if you do it in degrees. Okay, so there's your answer. Okay, pick another angle, 31. Okay, do the tangent of 31. That's a quadrant 1 angle, so it will come out positive. Sine of 84.9 comes out positive. Okay, any angle in quadrant 1, all the trig functions are positive. Okay. Quadrant 2, there's only one trig function that comes out positive in quadrant 2. Which one do you think that is?
Sine.
The sine. Only the sine is positive. Okay, so let's pick an angle in quadrant 2. Somebody give me an angle in quadrant 2.
132.
132. Let me take the sine of it. Sine of 132 comes out positive. Okay, let's take the tangent. Comes out negative. Take the cosine. Comes out negative. The only trig function that is positive in quadrant 2 is the sine. Okay. Which trig function do you think is positive in quadrant 3?
Tangent.
Yep. Only the tangent is positive. And which trig function do you think is positive in quadrant 4?
Cosine.
Yep. Only the cosine is positive. Okay, so this chart is very important. Okay, so the first one, I'll do graphing it, just so you can kind of remember how we did it before. And then I want to do it using this chart. Okay, so I'll leave that up, and let's try this one. Okay, so sine of x equals 0.6. If I was doing it on the calculator, first thing I would do is press y equals. And I got to clear everything. I got to type in sine. I got to type in 0.6. I need to set my window to 1 cycle. Okay, so this is all stuff we did before. Okay, just showing you how long it's taking me to set all this up. Okay, what's the cycle length of sine in degrees?
Is it 90?
0 to 360.
0 to 360. Okay, that's a full cycle of the sine function. So I'm going to set my x min at 0. I'm going to set my x max at 360. Okay, how high and low does sine go?
Negative 1 to 1.
Negative 1 to 1, so that's okay. Negative 2.5, I must just have that in there from something else. Okay, so now I'm going to hit graph. I'm still not done, I'm waiting for it to draw. All right, and what do I have to figure out now?
Where it crosses.
Yep, where it crosses, so now I got to do second calc, intersect. Okay, I'll move my cursor. This is taking a long time. This is not a quick process to do it this way. Okay, there's my first answer, 36.87. Second calc, intersect. Now I'm finally done. And the whole process took me at least a minute or two to do all that. Okay, so now let's do that whole
They're the
process.
same.
Yeah.
Well, it should be 143. For some reason, it just
Interesting.
it's not grabbing the current screen.
Oh, okay.
Well, what was it? 143 point something?
Yes.
143 point something. Okay, I remember what. Okay, so there's our two answers. Now, let's do that without graphing. I'm going to show you how much faster it is. I want to solve for x. All I have to do is get rid of the sine function. How do I get rid of sine?
Take the
Inverse.
Yep, take the inverse sine. Do it on the left. Do it on the right. And now just type it in. The inverse sine of 0.6. We already got our first answer, 36.869. Okay, that was a lot faster than having to set the window, graph it, find an intersect. Way faster. 36 point, we'll call it 36.87. that answer is only that one. That answer is going to repeat again and again and again. It's going to keep repeating. How often is it going to keep repeating?
Every cycle.
Every cycle. And how long is a cycle in this graph?
360.
Yeah, we wouldn't want to say 2 pi because we didn't do radians. We could have, but we did degrees. So I want to put plus 360 n. That means if you add 360 one time to that number, you'll get the next answer. If you add 360 times 2, you'll get the answer after that. If you add 360 times 3, you'll get the one after that. So you can keep adding 360 or subtracting as many times as you want. All right. So now the second answer, that 143. That's where the chart comes in. Okay. Still going to be faster to use this chart than to have to graph it and do all the intersect stuff. Look at the original problem. It says sine of x equals what?
0.6.
0.6. What kind of number is 0.6? Your choices are a positive number or a negative number. It's a positive number. So if you look at this chart, there's only 2 sections in that chart where the sign would ever come out to a positive number. Where's one quadrant that happens?
1.
Quadrant 1. We already have that answer, 36.87. There's one other quadrant.
Quadrant 2.
It's going to be in quadrant 2. That's the only other quadrant that sign comes out positive. Okay? That's your reference angle, 36.87. What do we do with that to get the next answer?
You subtract it from 180.
Yep, take 180 and minus that answer that we just got, and there's your 143.13, which is what the other answer was. Okay, 143.13. And what do we put on the end of that to indicate that it repeats?
Plus 360.
Plus 360 n. So that's how you solve it without graphing it. You use inverse trig to get your first answer, and then you use this diagram to get your second answer. All right, let's try, let's do a different one first. We'll come back to cotangent. Let's do cosine of x equals 0.9. What can I do on both sides to get my first answer?
Take the inverse cosine.
Yep, inverse cosine 0.9. You're already halfway done the problem. If you were graphing it, you wouldn't even have done your window yet. All right, so that's your first angle, 25.84. And how often does that answer repeat? What's the cycle of cosine?
360.
That is also 360. Yep. The formula, if you don't remember, to find the period of sine, cosine, secant, and cosecant is, well, it's 360 divided by b. b is what's in that box right there. In this case, it's a 1. Right, so the period here is 360 divided by 1. If there was a 2 in that box, your period would be 360 divided by 2, or 180. All right, now, second answer, I already know it needs a plus 360. I just need to figure out what it is. What trig function are we working with in this problem?
Cosine.
We're looking for cosine, and we're looking for where the cosine is
Positive.
positive. What are the quadrants where cosine comes out positive?
1 and 4.
Okay, 1, already have it. Okay, you got that answer. We need quadrant 4. So what do you do with this angle if you want to get an answer in quadrant 4?
Subtract it from 360.
Yep, so 360. I can just do minus, press the second button, and bring up the answer that I just had. Then I don't even have to type it in. and I get 334.16. Okay. Let's check it. Take the cosine of 334.16. When I hit enter, what should I get? I should get about 0.9. I get 0.9000 because I rounded. And if I do cosine of 25.84, I get 0.9 again. So that's how you can check your answer. If you plug it back in, see if you get what you started. All right, so we did a sine, we did a cosine. Let's try tangent. Tangent of x equals negative 1.8. Just as a reminder, the period for this, that's the formula. Pi over b, or 180 over b if you're doing degrees. Okay, what can I do on each side to get my first answer?
Take the
Can you
inverse.
stop real quick?
Yeah. Take the inverse tangent of negative 1.8. And that's your first answer. Negative 60.95. And how often is that answer going to repeat?
Plus 180 and
Yep. Okay, second answer. It's going to have a plus 180 end. And what do we call this again? This is your what angle?
Reference.
Reference angle. And what did we say about the reference angle? It always has to be what kind of number?
positive.
It has to be positive. So when we use it as a reference angle, it's fine to write it like that for the answer. That's right. But when you use it to get your other answer, use 60.95. Okay, reference angle is always positive. Okay, what trig function do we have?
Tangent.
Tangent, and we're looking for where it is negative. Where is tangent negative?
2 or 4.
Tangent is negative here, and it's negative there. Where's negative 60 degrees? Which quadrant?
It's a 2.
2.
That's one.
Wait.
Negative 60.
Wait, no, that's.
No, positive 60 would be in quadrant 1.
Oh, 4.
That's in quadrant 4. That means negative 60 clockwise. Okay, that puts you like somewhere
Yeah.
down there. Okay, so that's quadrant 4. We got that answer. What do I do with my reference angle to get an answer in quadrant 2?
You subtract the absolute value from 180.
Yep. So I'm going to do 180 minus 60.95. 119.05. Right, let's check it. If I take tangent of 119.05, what should I get?
Negative 1.8.
Close enough to it.
I get negative 1.800. Yep. And if I take the tangent of negative 60.95,
Should get close to 1 negative 1.8.
negative 1.8 again. Yep. And I do. So very easy to check your two answers if you plug them back in. Okay. Any question on that one? So that's a sine, a cosine, and a tangent. Let's try a cosecant. If you had a button for this, what would you want to do on each side right now?
Do the inverse cosecant.
You would want to use inverse cosecant. There is no inverse cosecant button on this calculator. So we have to think of it differently. Cosecant is connected to which other function when we flip it?
Sine.
It's connected to the sine. So if you know the cosecant, then you do also know the sine. What would the sine be in relation to that number?
The reciprocal.
It would be the reciprocal of it. Yep. So that's the first step. If they give you a problem that you don't have a button for, you need to convert it into a problem that you do have a button for. Okay. So take 2.4, flip it. and that's the sine. Same thing if they gave you cotangent. We don't have a cotangent button, or we don't have the inverse cotangent button, but he has it on his calculator. Yeah, it's a little different. So if you don't have it, it's not a big deal. You just take the number they give you and flip it, and then you'll have a button for it. Okay. Now, what would I type in on my calculator to get my first answer?
The inverse sine.
Inverse sine, yep.
1 over 2.4.
1 over 2.4. There you go. That's your first answer. 24.62. 24.62. And how often is that answer going to repeat?
Every cycle.
Every cycle, which is
360?
360. Remember, the formula is 360 over b. I'm looking at what's in front of the x. It's just a 1. So my b value is 1. 360 divided by 1. Okay. All right. What trig function are we working with right there?
Sine.
Sine. And we want to know where the sine is what kind of number?
Positive.
1, that's positive 1 divided by positive 2.4. That's a positive. So you need an answer in quadrant 1 and
Quadrant 2.
quadrant 2. That's where sine is positive. So what am I going to do with the 24 to get my other answer?
Subtract it from 180.
Yep. So 180 minus that answer, 155.38. And if I type that back in, the sine of 155.38 should come out to what?
1 over 2.4.
Yeah, whatever 1 over 2.4 is. Let's see. 1 divided by 2.4. Yeah, we got 0.416. It's supposed to come out to 0.417, just the rounding. Yep. But those are the same. Okay. So any question on that one? That just has that one extra step, at least on my calculator. Okay. Any question on that? Okay. So those, not a ton of questions, but those will be the questions for tonight since we did not have a test. I think it's 10 or 11 questions.
So do we have to have these back to you for next academic Monday?
Yeah, we'll look at that next academic Monday. Yeah. So page 394 and those questions.